Tacoma Bridge, Washington, opened only a few months ago, was built at a cost of over $6 million. But misfortune overtakes the great structure. These are some of the most amazing pictures ever recorded by a newsreel.
Assalamualaikum and hi everyone. Our project is Tacoma Narrow Bridge or Galloping Gertie. It was built at Washington, United States. It started at September 1930 and finished at July 1, 1940. And it collapsed in November 7, 1940. Engineer, the cause of the collapse in this division is the material, which is steel, have reached its maximum elastic limit. That is why it can be collapsed. So, the way to prevent it from happening again is we must calculate and investigate maximum elastic limit of a material. So, when a force was up to the materials, and the materials have higher elastic limit, it will eventually have lower risk to collapse, because when the stress limit is removed, the material resumes to its original size and shape, as if the stress beyond the elastic limit can cause a material to yield or flow.
I, as an environmental engineer, after studying what can I conclude? That the Tacoma Bridge collapsed especially due to the aeroelastic flutter that was caused by high-speed winds that matched with the natural frequency of the structure. Okay. So the collapse of this bridge is due to the wind-induced resonance. What is resonance? Resonance, which is where a periodic force syncs up with the natural frequency of a system. As example, swing. With resonance, small periodic during force, like pushing someone in a swing, can add up to large oscillations over time because energy is stored. When these alternating zones at low pressure occur at a frequency near to the natural frequency of the structure, even small amounts of wind can lead to major oscillation. This example is related to Tacoma Bridge that experienced resonance from the vortex shedding. The side of the deck of the bridge, there are flat beams called girder. They are long, narrow, and shallow, and do not allow any wind to go through it or even direct it in different direction. The wind pushes up against the girder and it acts like a blockade, and the pressure of the wind causes swinging of the bridge. So, there are two suggestions to avoid the bridge from collapse. The first suggestion is to put holes in the girder so that it would be able to wind through easily without being blocked. The second suggestion is use curved girder to divert the wind so that it will not push against girder like a blockade. It will decrease the amount of swinging of the bridge deck. This can allow the wind to
Resonance is a process in which an object's natural vibrating frequency is amplified by an identical frequency. There was very little resistance to torsional forces on the bridge due to having such a large depth-to-width ratio of 1:72. Along the side of the deck of the bridge, there are these flat beams called girders. They are long, narrow, and shallow. They do not allow any wind to go through it or even direct it in a different direction. The wind pushes up against these girders and it acts like a blockade. And the pressure of the wind causes swaying of the bridge deck. Before agreeing on a final design for the bridge, there were many suggestions that were put around. One suggestion was to put holes in the girders so that wind would be able to flow through easily without being blocked and used as a blockade. If you have a flat girder, it completely blocks it. If there are holes, there is evenly proportioned airflow. Another suggestion that someone made was to use curve outriggers to divert the wind so that it wouldn't push against it like a blockade, and that would decrease the amount of swaying of the bridge deck. This would have allowed the wind to move around the bridge without affecting the movement of it or direction of the movement. There were many other suggestions made, although none of them ended up being put to use.
Hello, my name is Nushazwina binti Kamaruzaman. I am a structural engineer. Okay, the problem seen by the Tacoma Narrow Bridge is because of elastic flutter.
This phenomenon is called aeroelastic flutter. It's the same reason that a strap or sheet of paper vibrates in the wind. It's a completely separate mechanism than resonance from vortex shedding because the periodic forces are self-induced from the naturally unstable aerodynamic shape of the bridge.
Okay. Next, Tacoma Narrow Bridge constructed with relatively wide and slender deck. When wind blew down the valley, the same effect occurred, causing the bridge rotate and twisted along its length.
The wind. Any small amount of twist in the bridge created vortices, or areas of low pressure, in locations that actually amplified the twisting motion. Each time the bridge returned to its natural state, its momentum twisted it in the other direction, where the wind could catch it and continue the cycle.
Okay, the other problem caused the Tacoma Narrow Bridge to fall down is because the platform had no holes at the side of the bridge. It can't allow high air resistance to go through the bridge, so the bridge will swing. Furthermore, Tacoma engineers invented the bridge with 8-foot plate girders, made the roadway shallow as well. The relative smallness of the deck and its limited rigidity made it easy for wind to move it, so it will be swing like a pendulum. Ways to improve or solve the problems by curving the side of the bridge like fins shape, so it can cut through the high-speed wind. Then, applying the aerodynamic principle, the bridge will be less swing. Okay. Besides, we can put holes at the side of the girders so air can pass through the girders. It will not push the bridge and reduce the lifting forces at the bridge. Okay. Lies, widen the deck so the wind can easily lift the bridge, so it will prevent the bridge from swinging. Okay?
Which is essentially just a deck, 2 towers, 2 main cables, and connector rods which suspend the deck, hence the name. The primary advantage of suspension bridges is that they can so efficiently span long distances with only 2 towers, reducing the amount of material required and, more importantly, the cost. This advantage of being able to span long distances while minimizing material gives suspension bridges their iconic slender and graceful appearance. But that same lack of material reduces the rigidity and stiffness of the structure. Where before bridges were generally stiff enough that gravity was the only load that needed to be considered,
Tacoma Narrow Bridge. This construction are located at Tacoma, Washington, USA. Completion of this construction are on 1940, and the cost for build up this construction are 6.4 million, and the length of the construction is 7,392 feet. The purpose of this construction is for roadway. This construction are built up from steel and the concrete. And the engineer for this bridge are Leon Boisnes. The design of this bridge is ultimate cylinder bridge. As a construction engineer, this construction failed because the material use is not suitable to the condition of the environment. Then another fact of the failure is the cost to build up the construction was too cheap. And this construction have to be strong enough because the area has a high speed wind. Then another failure is duration of time to finish it is too quite short.
On November 7th, the bridge suddenly went into a twisting motion. The wind speed was a steady 42 miles per hour. This was enough to keep the bridge oscillating in one of its natural modes of vibration, with a period of 5 seconds. A professor of engineering went out to see what had happened. He's coming back, walking with some difficulty along the nodal line, which is the center stripe of the roadway.
To avoid this situation happen again, the construction engineer needed a high cost to build up this bridge, so it can use a high quality material, so it will be safe and be a strong structure. The second one is we also need to have a little bit more time to make sure the construction work would be more detailed and strong. As example, the Golden Gate structure. This construction can be one of the model to this structure to look up to, such as the cost of the Golden Gate is 27 million, but the Tacoma Bridge are more cheaper than that cost. This construction may be needed for years to finish the construction work. It may take a long time to finish to get a good quality. So this is all the factors why the Tacoma Narrow Bridge is collapsed within 4 months. Thank you.